We made it.
We did it, man. That was really tough getting here.
Yeah.
Every day, though.
Well,
Every day, if it's a Friday or
Saturday.
We get here. Looks like your hair's cut a little bit.
It isn't.
Yeah, I feel like I should know that. It's your dad,
Yeah.
right?
It's fine. It's not cut.
Yeah, it looks good. Should we get right into it?
Yeah.
Did you have anything interesting for breakfast this morning?
I had an omelet. It was good.
Omelet? Did you make it yourself?
Yes.
That's what I'm talking about. Good. All right.
What happened last time?
All right, let's switch over to Campbell's machine.
Yes.
Give it to us, Campbell.
Yes.
Tell us a little bit about what happened.
So last time we finished the entering superscript mode. So I don't think we have it exactly how we want it, but we have something. So we, as you can see, we're in superscript mode, sucker. And when we type in numbers, they go up here. And we can hit escape, enter the plus sign, the division sign, the multiplication sign, or the subtraction sign to exit this. Oh, wait, no, not subtraction.
Yeah.
Only addition.
Space should work.
Space also works, yeah.
Yeah, get out of the mode. And the mode's indicated by that green border
Yeah.
right there, and the text underneath. We could probably change that text to be a little more professional.
I think it's okay. And we also have negative, a negative sign for the powers.
Now, you're doing these on numbers, but we actually all right, we just crashed.
We did.
OBS crashed on us just instantly while we were broadcasting. It's crashed twice on us this morning. Once before we started, and once just now it's shut down immediately. Let's refresh this again here. But
yes,
good, Campbell.
we have support for displaying these numbers, but as you were saying, I believe, we still don't have support for calculating using these.
Okay.
Like, we can't do this plus 4. Or...
Yeah. Give me 1 second. How's my mic sound now? It's like, is it just low maybe? You sound very distant.
Well,
Interesting. Is what suggesting I'm sounding distant. How's that? Maybe better. That might be a little bit better. G-Man, thanks for that feedback on there. Appreciate it. Yeah, we got a little bit thrown by that crash that just happened a second ago. Campbell was in the process of showing us
so, yeah.
what we did last time.
Currently, we have support for anything like this, a mixed number or even a decimal. And we can add those to a fraction or another mixed number or anything. Or
And get a result.
And, or, divide anything. But we do not have support for the powers. Yes.
And we're really kind of also we don't have support for powers for numbers, but we do have support for powers for units.
We do, that's right.
Thanks, G-Man. Appreciate that. So here we can put m squared, for example, meters squared. And what we need to do is there's one bug in this that we kind of need to get to. What's this? Oh, it's a breakpoint. Oh, good. This is the breakpoint I wanted to hit yesterday when we stopped the show.
Yeah.
Give me a second. Let me start up some music
for
here.
some reason. It doesn't work if you have a decimal and then a unit with a power.
I'm not sure about whether it works or not, but right now I just want to get to this point. So right now we're going to regex helper and we're calling get value. And the problem is that if there is no power found in the regular expression, which is like right identified by this right here part of the regular expression, right? That looks, is that right? Am I getting all the parens right? It's from there to there, I think, which is the power we're looking for.
No, not quite. It's a little bit before that as well.
You mean this part?
Yeah, and the paren before that.
Oh, do we have that? Is it this? In other words, do we have the caret symbol followed by a number, which is, here's the number, and we're calling it power, or do we have simply just a superscript power, which is defined as, let me just scroll it up to the right so you can see it.
Which is the one we are using, because you can't have a caret in our current code, the way that we've written it.
Right, and the problem is that if we just to say meters, we get none matches here and no matches here, which is okay because they're both optional. But when we ask the question, what is your power? We ask for we go into call get value, passing in a type of double. This is a generic method, Campbell. We learned a little bit about this before. And what it does is it tries to find a match. Here, let's see more of the code here, right? If it finds a match, we return it. Okay?
Yeah.
If it doesn't, it returns the default of T. T is the type that we're passing in, right? See it right there? So this works on all these different kinds of types. So get value of double returns, if it doesn't find power, the default of a double. What do you think the default value for a double is?
I would assume either 0 or 1.
It's 0. The problem is this, so if I have M all by itself with no power specified, what's the real power on that?
1, or is it 1?
It's 1. So we need to change regex helper to actually accept a default value if not found. Default value if not found. And what's the type of this?
It's just an int.
Well, or a double in this case, right?
I guess.
But
it's never going to be it's never going to have a decimal point because it'll just be 1.
Okay, but so in terms of types, I've got choices of double, strings, booleans. What's the type going to be?
Double.
Okay, that's if we call get value, passing in a double. But look, we're also passing in a string to it.
That's true.
What's the type going to be if we pass in a string?
It's just going to be a string.
Right. So, exactly. So, in order to specify that here...
We're going to have to be able to use both of them because we have the power, which doesn't count as a number.
Right. By the way, go ahead.
And we also have just the regular number that we use in the code.
Yes. So, by the way, when we call get value, T is a double. When we call it from the place we were talking about, it's actually double. I could use T right here to say, hey, default value of not found has got to be of type
Double.
T.
Or T.
Double, yeah, or string in the other case. And then I can do one more thing. I can make it optional, because right now I've just broken everything. By adding a new parameter, everybody's like, sorry, you're not specifying that extra parameter. See, it's broken?
Yeah.
And it wants a string default value. Well, I don't want to specify that.
So we need to make it optional, like we were saying.
Yeah, an optional one, which means I initialize it to a value, and the value I want to initialize it to is default of T. See it?
Yeah.
Okay, see that?
Yeah. Okay.
All right, open up our Reg Explorer project, our Reg Explorer solution.
Reg Explorer.
We want to change that code so the regex helper class, you don't have to run it. Just somewhere in our generator, we want to find the code that generates the regex. I think it's called regex helper. Show you a quick way to do this. First, we're going to find the name of the class. Regex helper, that guy. I'm going to copy it to the clipboard, come back over here, Control-Shift-F. Go ahead and press Control-Shift-F. This means find in files. Now paste what I've got on the clipboard there for you. And just say find all. Because this is going to show up in a string somewhere. It's in code generator. See it down there at the bottom? Highlighted for you? Yeah, double click on that first one, the first line there, where it's got it highlighted in purple background, in a brown background. There you go. Okay, there it is. See it?
Yes.
Okay, so change that So it looks like the code we just changed in the other file, back in the other solution.
Okay. And then here we want.
I just copy it. I think I think copying this might be the fastest
no,
way.
you copied it. Oh, all right.
Alt tab over is gonna get it for you. There you go. That's what we want right there. Default. Wait. There's one more change I got to make to it. Oops. Guess who forgot to make one important change? We're not actually changing the code itself yet. Now instead of returning default of t, I want to return default value if not found.
Okay.
So now what that allows us to do, the fix is this. In, where is it? I think it's in FindUnitPower.
Yeah.
The fix is this. So now if power is not found, and if superscript power is not found, this is going to be a string. We're going to pass in 1.
But the power version, right?
But the what?
But to the power, right?
That's for the power, right? Because look, we're asking for superscript power. So what that means is superscript power is going to come back, oh shoot, oh you're right, this has got to be that char map version of it. Is that what you're saying?
Yes, that was what I was.
My bad. You're right. Copy that.
Oh yeah, there's the 0.
That's what we got to do. Okay? So that's exactly right, right? So perfect. Now we can do that. Now the only thing I want to do though is I want to clean up our code generator. So code generator is this good, which means it's got to return that. Does the code generator just have the entire method in it? It does. See that? We can just take the entire method and paste it in. So let's do that. A fast way to copy the entire method is put the caret there and hit copy. Just hit Control C. Coders will just select the whole thing for you. Now go into the other one, Alt Tab over. And now we want to select this guy. This one you're going to have to manually select from the word public on line 41 all the way down to the end of it, which is right there on 60. No, I'm sorry, it's on 63.
Yeah, okay.
Okay, and then paste. And I think that's all we have to do. And I think that'll get us a new high quality one. We should probably test the other now to make sure that all works.
Yeah.
And I want to add some test cases to verify that. Let's save this before we leave it. Save that. So you got that change saved. And let's go back over and let's go to FindUnitPower. And what I think I want to do with this is I want to create a new test case for this. So what do we have over here? Test unit powers. Oh, cool. We've already got something here. Test unit powers. Sweet. So let's create a new test method for this. Can you do that for me?
Yeah.
Create a new test method. Test FindUnitPowers. I think FindUnitPowers is on the clipboard. You might be able to paste it in right there. Good. And maybe an S on the end or whatever. That's fine. All right. Now I want you to paste that in again and type in .create after it inside of the method. So we're going to create a new FindUnitPower.create. There you go. And pass in a string that's just meters, or M. Okay, like that. And let's do a hit the coders key and choose declare local. And look what it's going to do. It's going to declare a local variable that's equal to the result of that. It knows the type of it is type FindUnitPower. Perfect. Just copy that to the clipboard. Hit end and then enter. Get down to the next line. And down here, paste that in, dot, and let's see what our properties are on it. Power. What do you want to? We want to test to make sure that it gets meters as meters and power as what value?
As whatever the power is. So 1.
Right. So we need to make sure that this power is 1. So you can select this whole thing, FindUnitPower.power, and cut that to the clipboard. And we want to do essentially like an assert. Do you know which one we want to call? Assert dot what?
Dot
to
true.
Check.
Or like, yeah, assert dot true.
You could do that. So how would you do that? Do it just type in AT if you got Code Rush. There you go. And so we're going to basically now need to make an expression that's going to evaluate to true or false. So you've got power is, what's the test?
The first parameter is what you're expecting it to be, right?
Oh, that's if you use R equal, which is up above on line 31 and 32 and 30. That's for if you use R equal. If you use is true, it just takes a simple Boolean.
Oh,
So you can say power double equals 1 as you're expressing, for example,
got it.
if you want. Right? Which
Or
is cool.
You could do
Go ahead.
assert.r equal, and then
Yeah, let's try the same thing down below. Go down to the next line and let's do the same kind of test with R equals and let's compare the two. So this, for this, do you know what the abbreviation is to get it?
AE.
Try it. Okay, expected value.
This is 1.
Okay. And there you go. Now the cool thing about the second line is that it gives you more information in the report if there's a failure. The problem with with 37, line 37, is it just is going to say
It wasn't equal.
it wasn't true. And it won't even tell you anything about what it was or anything. It'll just tell you the name of the test method it was
Whereas
trying.
with this, it will say expected 1, but was FindUnitPower.
Right. Why don't you do an R equals on the units too to make sure that it finds M as the unit and yeah.
Oh, that's not what I wanted. Oh, this needs to be a string.
Good. How you doing, G-Man? Welcome to the show. All right, can we run this test case and make sure this works now?
Yeah.
You can just click the one. There you go, that one. Yeah. Results over there. Looks like it failed.
Oh, this one failed. Oh wait, but that one
Okay,
didn't have
so we
the-
don't have a lot of information. We just know that power was not there.
Forgot
It
to
could
get
be.
rid of that one.
It could be too that power's actually null
Expected 1, but was 0. Yeah, okay.
for power.
But if power is null, it wouldn't say that it was 0.
You're right.
Null is not the same.
No, you're right. So it is finding 0. The question is why is it finding 0? Get value. I think we're going to have to step into it. That's what I think we're going to have to do. Let's set a breakpoint here, and let's debug the test. Maybe here too. Okay? So go back to the test and debug it. Actually, it's overkill to have 2 breakpoints back to back like that. We just really need the
Which
one.
one was it in? It was
Test unit power is the one that's highlighted. It's down near the bottom, I think. Yeah. Okay, so let's step into this. To step into a method call, it's F11.
F11.
Right. And now let's see what we got in matches.
So,
Just hit F10 and let's just kind of explore and see what happens as we kind of go through it. So we got a match on M.
yeah.
Uh-oh, what's this?
Uh-oh. Well, oh, do we have to change this method?
We do.
Because it shouldn't be return default T. It should be, what did we change it to? I forget.
Line
Default
30.
value is not found.
Yeah, right there. I just copied the clipboard and pasted it up there. You can probably run it. You can probably have F10 to run it, and it'll probably return that value. Nope, doesn't like that. It continues sometimes. And so go ahead and stop it, and let's run the test again. Okay? Run the test again.
So this time we are expecting it to work.
Maybe. Yeah, so we can do a run test instead of debug. Happy to do that. Yeah, it passed.
Yeah.
Sweet. That's what we're looking for. All right, good. So we found it. Oh, what do we have to do? We just fixed regex helper.
Oh, right. We need to change it in regex.
Yeah, we need to change it over in the Reg Explorer part that generates that code because that's generated code. So it's line right there. It's on line 53.
Is it still on the clipboard, do you think?
No, but it's done on line 62. You can take line 62 and copy it and put it up where line 53 is. Yeah.
Okay.
And there's no T in there.
Here?
Yeah, the T isn't, the paren T is only a parameter to the word, the keyword default.
Yeah.
So, okay.
That was not what I wanted.
So save that. Good. Good. All right, next. I think the next thing on our list is we have to go look at our failing test cases. Let's run all our test cases one more time.
Okay.
Good
This
thing to
one?
do, right, when we make
Yeah.
changes. Let's go explore the
This
ones
one
that are
is going
failing.
to fail. Or we don't want to fix yet.
What do we have here? Wait, what's this? R equal get
Oh.
power. Let's go look at get power. This is, I'm not quite, yeah, I want to go look at get power. Find unit. If unit is equal to null, return 0. Otherwise find FindUnit.power. Let's go figure out what's going on with this one. Let's explore this test and figure this out. Is that okay?
Yeah.
All right, so we want to debug it. We want to set a breakpoint, and let's go back and to the test case itself and set a breakpoint on line 30. And I want to kind of jump into toNum is what I think I want to do. Let's see what's going on with toNum. So F11, to just jump into it, it's the first method that we're going to call on here, I think. All right, go ahead and F10. I think you're going to get to the last line of this, as I recall. Now F11 to jump in here. Okay, that's okay. You're just doing initialization, so F10 on this. Wait till you get to the constructor. Then now you're in the constructor. This is where things are interesting now. Okay, so you're passing in 1 space M caret 3. So
Yeah.
M to the 3rd power. So just hit F10, and let's see where we jump to. All right, so we're going to call FindNumberUnit. So this is one of those classes, those regex classes we built, that basically finds the number and the unit. Okay?
Yeah.
And so
Yes.
it's going to return a value if it finds, it's going to return something not null if it finds a number and a unit. So hit F10 on that, and it says it's not null. See, it says false underneath there. See the word false written down right underneath line 61?
Yeah.
That's basically CodeRush telling you that is not true. And you even see there's a little bit of de-emphasis going on this path. See how this is not as bright as this path right here?
Yeah.
See, this is a little darker. That means this, we're not going here, we're jumping in here. Okay, does that make sense?
Yeah.
It's just a preview of where you're going to go. Okay, hit F10 and F10, and let's see what we get there. So number string, find number unit. Hold on.
That's weird. Number string is null, but find number unit dot number blah 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 is
Wait.
equal to 1.
Well, number string is null because we just declared it and we haven't set it yet. We're about to set it. So it's telling you what this is equal to now.
Oh right.
Before we
about to go through this.
Yeah, we haven't executed the line of code. Watch what happens when we execute it. This will change to 1
1.
and it'll be red to indicate that it's changed.
I accidentally pressed
Go ahead and hit
F12.
F10. Oh, F12, that's why we're jumping up. Yeah, F12 jumps up to the declaration. All right, hit F10. So that's the number part of it, the
Yes.
1.
Now it's 1.
Now it's on to the units. And now we're checking to see if we can split the units up because maybe there's more than 1. And they're not. Hold on. Let's not go too quickly here. Okay, it looks like we stopped. We may have hit F10 on something. Okay, there. Look, the power is 3. See it? Okay, good. I think I see what the break is happening here. So watch what happens here. If superscript power is not found, we may not want to change this to a 1. We may want to change this. Well, here we can change it to 1, but here you might want to make this a null. Because watch what's going to happen. It doesn't find the superscript power, so what's it going to set to?
It sets it to 1.
Yeah, we want to change this to null,
Okay.
which is a valid value for a string. So I think this is going to fix it. So hit F10 now. Let's clear this breakpoint, and then we'll get out of here. Shift to F11. We can break you out of where you are if you want to. All right. You good?
Yes.
Just keep going? Okay, so F10 here. And I think we're going to see that it works. Yeah. See what's happening? This line of code was, well, it found it. See?
Yeah.
So, all right, so keep going. Now we're not going there anymore because we returned null for that because we didn't find it. Now we're going into AddUnitPower. Go ahead and jump in there. I think this is going to work now. Go ahead and run it. Just hit F5 to run. It passed. You can see it right up there. Test is passed. You can double click that too to get to it and verify that that now has passed. Okay, good. Let's look at test units and variables. Okay, this one. One bird is equal to one bird. I want that one to pass.
Yeah.
See that? Let's go. Let's double check that. Let's run only this test.
I want to see what it thinks. It's just one, right? It thinks that it's just one. Oh, one bird.
Without a space. Is it also one bird to the one power?
Yeah.
Okay.
So we need code that says one bird to the one power is also equal to just one bird. Or something listed.
I agree. It's probably in display string. See display string, the call right up there at the end of the line? On the line we're testing? That's a property. It's not a method. If it was a method, it would have what? In the call to indicate it was a method.
It would have parentheses.
Parentheses, right. It doesn't, so it's a property. That's okay. It can behave the same way. It returns a value. You hit F12 to jump to it. All right, so now scroll that up. You can also close down the bottom window so we have more room for code here.
Okay.
Okay, so it's, see line 166? See the end of line 166 where I'm pointing to right there?
Yeah.
That's get units display string.
Uh-huh.
Let's jump in there first. So F12, there you go, or tab to next reference can get you there. All right, so what's going on in here? You wrote this code last time. So do you recognize this?
Yes, more or less.
Can you wrap your head around this and tell me a little bit about this?
So here we're checking. We have a for each method that's basically saying for every unit, or unit with a power.
Now, unit power combination. That's our class called UnitPower. For every one of those in UnitPowers. Tell me about UnitPowers. Do you know about what that is?
Yes, I believe so. It's the one. It's the property or field, I guess, whatever you want to call it.
It's a field, yeah.
And it says how many unit powers there are, basically.
Yeah, it's just the list of all the UnitPowers for this number.
Yeah, and
okay, we're going through each one of those, and then we're saying result plus equals
whatever the power is. So we're
right.
or whatever the unit is and the power is.
Yeah.
Right? Yeah.
So how do we change this? Let's take care of the one at the end. If the unit power is 1, how would we change it so we don't actually show the 1? Because right now it's saying birds to the power of 1, right? The birds is coming from this part, and the 1 is coming from the second part. See? This is where the 1 is coming from.
Okay. My first thought was to have an if statement that was saying if the power isn't 1, then do this. Ooh, but that you can't do in an interpolated string.
Right, so you could, but that's okay because look what happens here. There's a couple ways to solve this. You can't do it in an interpolated string, but you can do it outside of it.
So
right? Let's just look at this. Let's look at this for a second. I'm going to write some code that's not really quite making sense, but we know that basically, look, we either want to do this or we want to do that. Does that make sense?
Yeah.
Okay, now with that as a clue, can you figure it out?
I think I can.
By the way, if you want to see an example of an if statement, there's one down on line 142 on this page, just a little bit down below.
Yes, I know, but I can't use that in an interpolated string.
Right. but you don't have to be, notice, I just want to show you something, look. The one we had before, look, if I go through here each time, basically in one scenario, if the power is not 1, I want to do this. But if the power is 1, I want to do this. I have one of two choices. One of two different lines of code I want to execute.
Oh, okay. I got it.
You got it? All right.
I do. I believe. So here we want to have an if statement that says,
don't forget, if you have if, you just put a space and Coder will put the parens for you.
UnitPower dot power is equal to 1.
Yes.
Then we want to, is not equal to 1. Then we want to do this.
Okay.
Else.
For else, you just type in L and then space.
Yeah.
There you go. Yeah, that's it. That's the fix. That's a fix. There's another fix that you can do as well, where you create a variable that's going to hold the power. So you do something like this. You say, you do this. Whoops, I want to put that in a string. So I'm going to say power stir like this, and I'll set it equal to maybe nothing. And then I'll do the same kind of trick that you did here, where I'll say, okay, if it's not equal to 1, I'll say power stir is equal to that. Hold on. And I'm almost there. And then we just have one line of code that does result equals this plus power stir, like that. Does that make sense? So power stir is empty unless it's not 1, in which case we're going to set it to that.
Yeah, okay.
Okay. Does normal to superscript take care of the minus? I think it does. I think we wrote that so it does. Oops. It's not where I thought I was jumping into.
Sorry, that might be me.
No, I know why, because I was actually in a string. And it's not interpolated. That would not have worked. Now that works. Now I can jump into it. Does it get, oh yeah, it looks for this, I see, and converts it. So we do a 2-string call on it, then we're looking at each character in it. That's how we do go from normal to superscript. Okay. We don't have support for decimal points in powers.
We don't. Not in powers, nor fractions in powers.
Right. It's pretty simple. But for most equations that you encounter, you're going to get like m to the third or something like that. Right?
Yes.
So it's not bad. We're not building necessarily a product we're going to sell.
Wait, can I actually, I want to check character map and see if there is like a division symbol.
It's up high like that?
Powers. Yeah. I think it's unlikely that there is, but maybe, I think just checking is it.
I don't know. It's a lot. There's a lot of characters to check. There's probably like about 1,000 of them.
Yeah.
So it might take a while. But I would look for it up in the math symbols area. But yeah, wait. I might get an accent. So
that
like in this space?
Like this maybe?
Yeah.
Wait, I want to see how that looks now.
Yeah, it's a little, you need something more than that.
Wait, I want to just...
But you might be able to find something. There are some accents that are a little bit shaped like that. All right, I want to get, what'd you say?
Oopsies.
Let's do this after the show.
Okay.
Because, watching somebody scroll up through a bunch of these is maybe not as...
Not fun.
Yeah, do you want to undo my changes and go back to the code that you had before we...
I think it's okay. They both work.
Okay. All right. Cool. So yeah, that should now get us closer. Now there's one other thing. The reason I actually like this better is because now we only have one place where we're modifying result, which is important because we might also want to have a new variable in here called leading space. And we might have something in there where we say, okay, it's like that, but we might want to say, do something that says, hey, if we're the first time in, let's add a leading space. So we're going to create a Boolean up here, say first time in. And I'm going to set that equal to true. And I want you to think about what I'm doing because I'm going to ask you to take over in a second.
Yeah, wait. Can you say that again?
Yes.
I'm not quite.
Sure, no worries. Where's our test result? I want to go look at our test result. View output. Look at what's going on here. See the bird is right next to the one.
Okay.
I want to put a space there. I want a leading space if it's the first unit. I might have several units in a row. Okay, but the question is, do I put a leading space here or not? And so that's kind of what I want to do. I've added a first time in is true. Can you finish this code? And if not, that's okay because this is like the first time I think you've seen this. I can go. I can give you clues.
I think I can, but I'm going to need to think about it for a second. Wait, we need to make this a space.
Okay.
Do we not?
It's up to you. You're the developer, right? Oh, you're going to need double quotes for that.
Uh-oh, I've pressed insert. Really? Why?
Because a string is defined by double quotes and a char is defined by single quotes.
But it's just a space.
Right? It's just a space, but there's no implicit conversion from a char. Right? We're talking about C-sharp
and
syntax.
we're working with strings. Okay.
Yeah, C-sharp syntax from a char to a string.
All right.
You can do a plus on it. By the way, here's what's interesting about it. Look, so I know what you're thinking. You're thinking, wait, why doesn't that work? Why do I get an error there when all I need to do is, like, if I created an empty string and did a plus, the error would go away. Okay, what that means is there's an operator overload for char that's able to convert, and probably for string too, it's able to add the two together. Does that make sense?
Yes.
But there is not an implicit conversion, right? We added implicit conversion for our super number so we could implicitly convert it to a string or a decimal.
To num.
Yeah.
Okay.
Okay, so leading space, I'll show you where I was going. Let me do this. Let me give you one more clue. Is that okay if I give you one more clue?
No, I think I got it.
Okay.
So here we need an if statement.
Yeah.
And in here we want to say if first time in
Perfect.
is true.
And because it's a Boolean, you don't need to say is true.
Yeah.
Right?
Okay. Slight problem in where we placed this.
Nope, that's right where I want it. That one's in the right place.
Really? Because every time we call this, we will set it to true.
Yep. At the first time in.
Oh, right. And this is in a for
I'm worried about the loop.
Yeah. Okay. It's a for each. Got it. If first time in, then result.
So result, by the way, it's
right?
Nope.
Is this? No, this isn't the unit. Is
nope,
it? No,
nope,
this
nope.
is just the power.
You want to put it? I'll show you where you want to put it.
Wait. Oh, right. I think I see.
There you go. That's
Here.
where you want to put it.
Else.
Okay.
Else.
All right.
Boop.
Yeah, there's a lot of ways to do this. You actually don't need line 133 if you do this like this. You can get rid of line 133
Oh, right.
because you don't need that leading space anymore.
That is true.
Okay. Now, you want to delete line 133? All right. One thing you're missing, and you're going to need braces around line 34. This is your big clue. Line 134 is going to need braces around it. So you hit the code rush key, get the line up. Yeah, get there and hit the code rush key. Add block, add braces or something like that is what it's called.
It's add block delimiters.
Add block delimiters. Good. So you've now created a block around this. You need another line of code in here to make this work.
Okay.
And do you know what it is?
I very much do not.
Okay, let me give you your hint. If you don't put this line of code in here, every time, first time in is going to be true, and you're going to execute line 136.
Oh, right, first time in is false. Right.
There you go.
Right.
So just hit enter and then space equals F and then space. Go back. If you just type in equals F right there and space, code completes it.
Oh, right, I had double equals but that was wrong.
Okay, now that's right.
Yeah.
Now that looks like
I forgot to do that. I had it in my head that that's what I needed to do, but then I just was like, nah.
Okay, now there's another problem, slight problem. Or is there? Okay, first let me say you did this absolutely right. Okay, I want you to bask in the glory of that achievement.
Yeah.
And now I'm going to simplify it because I realized, what if we have several in a row? Well, if we have several in a row, guess what? We still got to put a space between it and the power before it. If I have, meters squared seconds, right? Don't I?
Yeah, so we can just...
So all we need is just simply to put a space there for every single one. It's just simply that, I think.
It was a single character.
Right? And we don't need first time in.
That's true, because we don't ever... You don't have meters squared seconds squared.
Right. It'll be, so our answer would be, we'd want something like this. So we want basically a space. That's how we want the units. Okay, makes sense? Now, looks like we might have fixed the bug. Because look at this, right? We're only... Right, you added that code right there. So let's go see if that fixes the bug. Let's do, where were we? Were we here? Yeah, here. Let's do this one. Can you do that? Give me a test run on test simple like units.
Yeah.
And I think line 54 is going to fail because of that space.
Yeah.
So I think we change it by adding a space there. And we essentially fix the test case like that. And because that's just the format we're going to do.
Maybe our code was reversed though. Maybe for the first one, we don't have this space. Maybe.
I don't know. I didn't like the one bird. I didn't like that.
Yeah, that's true.
And we could do this. There's another way of doing it. We could say, well, you know what? What if the unit was one character long? If it's one character long, we do this. Does that make sense?
Yeah.
And if it's anything else, we add a space because it's like a word. Because that's kind of the convention, I think, in math.
Yeah.
Okay. Well, if you want to do it,
Oh.
it's the space to do it is in here. How do we do? So now, all right, let me help you out.
Yeah, can we just Control Z until we're...
I'm going to do this, leading space. I'm going to get you a variable, leading space, and now I'm going to default it to a space, but now I want you to set it to nothing if the conditions are right to do so, if the length, essentially, of the name is 1. UnitPowers name.
Here, we want to say if...
Space. There you go.
What are the conditions? What is the thing? It's something.length.
UnitPower.name is this thing you want to start with.
UnitPower.name.
That's the thing you're looking for.
No.
And watch for IntelliSense because it'll help you out.
Power.name .length is equal to... oh wait, no. Is greater than or equal to...
No, I think it's just it's equal to 1
If it's
in
equal
general.
to 1, then the space, leading space, is equal to boom boom, semicolon, and we're done.
Yeah, what if I have, before we actually say we're done, should that mean that this is now comes back as that? Or should it be that? In other words, are we going to are we only going to want to do this on the first time, or are we going to want to do it on every single one? Because I could go with that, and I could go with this.
I think we should just always have it no space if it's one character.
Okay, so there it is right there. All right, let's go back and run the test case now. Now let's see if this passes. This should pass now. Let's run it again.
It is passing.
Well, that's because we
we
edited, I think. Yeah, okay, that's passed. All right, what is next? We have some math now we've got to be able to deal with.
Right, these pieces, right? Yeah.
Yeah.
So wait, here, I just want to update this piece on the side so that we know. So these are all passing. Passing. So we want to do
You want to run them all? Just run them all. Let's run all the test cases.
I did.
Oh, you did? Okay. What do we hit? What do we go with?
I think we should first do test like units. Let's test like units and then test like units division.
Okay. I'm noticing a problem with line 60. Line 60, we can't fix yet. Because we don't have the ability to hold two different numbers in a single super number. Does that make sense?
Right.
We don't have that.
Oh.
So we are going to need to move that to later. Maybe even I'll comment it out for now. We don't have that ability. We are going to build the ability though to do something like this.
Yeah.
So 1 bird squared plus 2 birds squared, right?
Which is 3 birds squared.
Yeah, although, to keep people from freaking out,
Because
maybe we
of
should change that just to an m. 3 meters squared. 1 meter squared plus 2 meters squared.
Why?
And we expect the answer to be 3 meters squared.
Why?
Why do I want to keep people from freaking out?
Yeah, why would
I
that
don't know,
change
just
it?
imagine thousands of screaming developers
But
out
why
there.
would-
You can't square a bird.
Oh.
And I'm going, yeah, well, you can if you're going to the second
Yeah.
dimension of birds.
What if the bird is... Yeah.
Okay, he's thinking of a joke?
No, I'm thinking of the way that the bird could be squared, but the bird can't be squared in any case scenario.
So anyway, we'll we have both of these test cases.
Yeah.
Okay?
Well, I mean, if you multiply a bird times a bird, it would be a bird squared, no matter
Yeah.
what.
Let's do another simple version of this as well. We have that. Okay? That's what we're looking for. Let's just see. I wonder if this one will pass. Expected 3M, but was 3. Okay, cool. All right. So let's go look at 2num. Just gonna drill our way in. 2num looks for a find left right.
Yeah.
If we can find it, it creates a super number out of the 2 different pieces.
Yes.
Then it just simply says, and then it find looks for the operator.
And it adds them.
Adds
or
them.
subtracts them.
And if it adds them, what we're talking about is going into the operator overload. Oh, look at that. Visual Studio, good job. Look what I did. I was right here, I hit F12, and it said, oh, F12 means drill into it. I'm on the plus, I hit F12, I drilled in, it found the operator overload.
Oh.
Nice job,
That's
Visual
great. I
Studio
love that.
developers. I love it. All right, so now we're inside here, right? And what's going on in this space here? We're creating a new super number. Do you agree with that?
Yeah. Well, we always create a new super number.
Okay. But we're missing units. Remember this?
Our problem is in find left right.
No. Our problem is here. We're not copying the units over from one of the 2 numbers. Okay. Got super number 1 and super number 2.
We're not doing it from either of them.
Yeah, I'm just going to grab it from super number 1. Let's just see
What if
that.
they're different though?
What?
What if they're different units?
Perfect question. Let's get to that in a second, okay? Let's first run the test case and see if we get past block the number 1.
We should get past. Yeah, we stopped there.
Sweet. So these all passed, right? Okay. Next. This one we want to fail.
Yeah, for sure.
And what we want to say here is maybe R not equal. Like that. And I think that's going to fail.
No, it should succeed. It's because you have are not equal. Whoa, why? Wait, so it's saying that they are equal to each other?
Yeah. Because it's copying the M from the first
from
super
there,
number
yeah,
one,
right.
right? And it's getting to the end here, and it's not really true.
But they are not equal.
Right. What I need.
So if our code was correct, it would think that that's.
Say it again.
If our code was correct, it would think that that's not equal to, so it would pass. But our code currently is not correct because.
Right. Right. The other approach to this is we throw an exception. We say, sorry, you have to have the same number of units. Maybe we did throw an exception instead. And we create a test method out here, test unlike units. With this, we put this in here, and...
Wait, we already have one that's like that. Do we not?
And I'm going to say expected exception, and we're looking for an exception that we want to put in there.
Don't we have like one bird plus two snakes?
Maybe. We'll find it, because we're going to make all these pass. I'm going to say I'm expecting an exception.
Right, we deleted that.
So what I want to do is I'm going to come in here and say R equal. Well, actually, I could just do this. I just need this call right there. Let's raise it. Let's throw an exception if they don't have the same units. Is that cool?
Okay.
And we'll create maybe our own exception. No, it'll be an argument exception. Maybe we'll do that. And so we're going to say we'll make an argument exception, which basically means one of the things you passed was bad. Okay?
Yeah.
What's wrong here? Do I need to do type of? Is that right? That looks right. Okay, so now this tells me I'm expecting it. So now what happens if we run this? This is going to fail now because we're not throwing that exception. Right? We're just, wait, yeah, it fails because we're not doing it.
Did
it
not
says,
throw
yeah.
expected exception.
See it? Isn't that so cool about test cases? Now we want to throw that exception. So now what I want you to do is go back over to SuperNumber, where in that constructor again, right? When we do, or no, wait, we know in the operator overload for the plus, right here, exactly right here. Give us more space. Clear that output view window below. Okay. And now what I want you to do is check to see if the units are the same between SuperNumber 1 and SuperNumber 2.
Okay.
And I think what I want to do is this. I think I want to do...
Wait, we can just... Yeah, that seems simple enough, but also... Ooh.
I think I want to do it like this.
There's
SuperNumber
something else that we need to do.
has matching units. What's the other thing we have to do?
For all of the plurals and all of the...
Oh, we have to do that check right there.
Yes, but we already have that check somewhere else, so we could maybe find a way to use that. Maybe.
So I'm going to throw I'm adding the code to throw the new argument exception here. We're going to say units do not match.
Yeah, in utility methods, I believe.
Okay. So has matching units. We want you to declare that for me.
Okay.
And we're basically comparing two different lists. I'm going to rename this SuperNumber to other SuperNumber, I think. So because this is an instance method, so we're going to have something in here called UnitPowers. We're going to basically need to compare UnitPowers with other SuperNumber.UnitPowers. We need to compare the two. There's no really great way to compare two lists to make sure they all contain the same values, because these are lists of unit power, which is our own custom thing. So there's nothing built in to the framework to do that. But what we can do is we can at the very least say, hey, look, if UnitPowers dot length, is it length count? If the counts are different, can you finish this for me? Then we'll return false. So if
Yes.
UnitPowers.count is not equal,
Isn't equal to the other, isn't equal to other unit powers, right?
right, other unit powers, other supernumber, sorry, other supernumber dot UnitPowers dot count. You can just use up or down arrow and hit enter. There you go, fix it. And then we want to return false. You want to hit return false?
Oh wait, it's just RF.
Right. Good. Now, to make this a little bit easier, because we're going to be working with comparing this with this, I suggest hitting the coder's key. Go ahead and do that. Choose introduce local down there. And pick either one of those two. It doesn't matter because there's only one of these right now. And call this other unit powers. So now it's just a little shorter.
Oops.
Okay. By the way, hey, if you ever have to get to the beginning of the line to change something, control left arrow. Hit it right now. Practice this. Control left arrow. And so you very quickly get to the very beginning of the word. Okay? Cool. So now we got other unit powers. So if the counts are different, then they can't be matching. Does that make sense to you?
Yeah.
Okay. Now that we know the counts are the same, we just have to iterate. I think the best way to do this is to iterate through all the unit powers. So I'm going to just do a for each here. And now I'm going to say, hey, does the other unit power, does this thing have it? So now in here I want to say this dot first or default, I think. And that takes a predicate, which is kind of a little bit of code, is what it is here. Like this, that's basically, I set a variable like X, and then I'm going to say, I'm going to compare the name, and I'm going to say the name is equal to UnitPower.name and X.power. You want to finish this? Make sure the powers match. So I'm adding two expressions here. So I'm looking for find the first or default where X names are matching and X's powers are matching. So I want you to do the second part of this right here.
Okay. Boop.
And I'll lean back so my head's not blocking that. Okay, good. Good. Semicolon. Coders will jump it to the end of the line. You hit the coder's key, declare a local for this. And call it found unit.
You know what I like about code? I kind of like that no matter how advanced the stuff you're doing is, you're always going to be using the same
Core pieces.
yes, if statements for each
Right.
statements for things, return, declaring methods.
So if found unit is not null, because first or default means the default for unit power, because it's a class, will be null. And so if we can't find anything that satisfies this, then we're going to return null. But if it's not null, that means we found the unit.
Yeah.
So actually, maybe we're more interested in this. If it's null, that means we did not find it. If we did not find a matching unit, what do we do here? And to answer, if you need a clue, look at the bigger context of what method we're in.
Well, then we need to say return, say false or true. It's false is my first instinct, but I'm not sure if that's the case.
Well, I can't find in one. That means what this means is I've got units in one that I can't find in another. So I've got two numbers. One's got meters. The other one doesn't have meters.
Oh, right. Because found unit is just saying that it's the same. It isn't saying. It's not saying that if we say if found unit is null, that doesn't mean that there's no unit. It means that the units don't match.
Yeah. Whoa! Look at this up here. Find unit. UnitPowers. Find unit. Hold on. I want to look at this code. Okay, I see. All right. See this? And this? That's the code that you were talking about. I'm going to extract this into its own method.
Oh, it is?
And we're going to say...
When? Oh, right, when I was talking about all of the
unit
singular
names
plurals.
match. Like that. But instead of passing in UnitPower X, I want to pass in just the name itself. See that right there? X is coming in, and we're just accessing name on that. When that happens, I can execute a really cool refactoring in CodeRush called decompose parameters. See it right there? Go ahead and hit enter on that. And it'll turn that X into a string. So now, and then changes the call too right there. So now we've got two different names, and I'm just going to call this one, I'm going to rename this one to Unit1 name, and this one over here to Unit2 name. Does that make sense? Unit2 name.
I really like this, how you can do this, where instead of having to create a bool, or not having to create a bool, having to set the bool of this bool equal to the outcome of this, you can just say return the outcome of this.
No, you're right. And we can do this like about 100 different ways, probably. Hold on a second. While I'm renaming this, I want to I think I want to take unit name 2 for this one and change this one back to unit name 1. Is what I want to do. Unit name 1. And like one of the things that you can do is, because look, we've got all these calls here, right? We could just call this, we could come in here and say, well, okay, let's introduce a local for this and call this singular unit name 2, right there. And duplicate that and get us the same with unit name 1, like that, right? So we've got 1 and 2, and then we might also say, we could do a 2 lower on that as well. Right there, if we wanted to. We could move the 2 lower calls up to each of these lines, which kind of make these, I think, a little easier to read when we do that. And now all we're doing, if we change these, we don't need that anymore. We don't need this anymore. It just becomes this. And, oops, let me go here and do this. It just becomes like this. Right? Does that make sense? I think that's easier to read.
Yeah.
Because we say, oh, we're doing the same thing on both. But we could totally do a thing.
I don't know.
There's a thing called inline temp. Watch. Inline temp takes that in there. And inline temp will take that over there. Because they're kind of like temp variables. You can do it either way. Yeah? Make sense? Do you have a preference? Do you want to change it back to the other one? Or do you want to...
Yeah, let's change it back to the other one just so that you can see it all at once.
There it is right there. Yeah, I kind of like that. Okay, so it has matching units. Back over here. If it's null, then we return false. Okay? We'll get out of there. So now, oh, wait. See this? Right here? What are we going to do instead of that? What if I've got bird and birds?
Right, we need to do the unit names match.
Right. Do you want to change that?
I think it's make singular, right?
No, it's just that. See right there? Look at line 523.
Just unit names match?
You've got this killer function called unit names match, and it makes them singular. Yeah, so we're just going to come in here and say, make the call to it. You want to finish it? Unit names match. I copied those 2 variables to the clipboard there. Open paren, close paren, because it's a method
unit
call.
names match. Oop.
And paste what I have on the clipboard and change the double equals in the middle to like a comma, because you're just going to pass those two in. See the double equals right there?
Yeah. So we are trying to find out whether or not these two have the same units.
Yes. Okay.
Even if they are singular, when they are singularized.
All right, so cool. So we found two cases where we can return false. If the count's not the same, or if we can't find the unit, right?
Yes.
Now, at this point, well, we have two issues. At this point, what's the answer?
Well, that depends on, well, whether or not the units are the same. Could be false.
Well, hold on. If the units aren't the same, we exit here. So when I say at this point, I mean this line, we get execution down here. We get out of this.
Oh, right.
What's the answer? So
It's false.
we've exited here and we've exited here.
We do not have matching units.
Wait, say that again?
We don't have matching units if we're here.
No, it's actually the opposite of that. So if you look here, if we don't have matching units, we exit, which means we never execute this line of code. We jump from here to the end of the method, right there, and we're out.
Oh, that's the end of the method.
Yeah. But if we get to here, if I have any code here, it'll execute only if we don't exit
So
here.
here we
don't
want to
exit.
say return true.
That's exactly right. Go ahead and give me a return true.
RTP.
Okay, that's the answer. So has matching units. So now, all that work, we should be able to get to that place where now this exception is thrown. I think this is going to pass now. Go ahead and run that and see if that passes.
Okay.
Pass.
Yep.
Passed. So now we've got an exception thrown when we have unlike units. Okay? That's great news. Let's go run all of our test cases. See if we have, the other cool, oh, you know what's cool about this, Campbell? Hold on, there's another test I want to add real quickly. And that is that I want to make sure that we're going to do the same kind of thing. Test unlike units too. I want to do something like this, but I want to have one of these like squared and one not. And I wanted to say, sorry, there's still unlike units, and we get an argument exception. Does that make sense?
Yeah.
That's what I'm looking for. Go ahead and run that test case.
It should totally still work.
My expectation is that this test case should pass. In other words, it's throwing the argument exception.
Because if you think about it, it's just accepting this as a unit. It's not as part of the unit. It's not accepting it as the power, or I guess it technically is, but
it's the power of it. It is. In fact, what makes this work is this. We check to make sure the powers are equal. If we were to take that out, if I cut that out right now, and I come over, I bet this fails.
Well, yeah.
Because it's going to consider them both the same. Yeah, it fails. So what makes that work is that secondary test right there to check the powers.
Yeah.
Okay, so now we've got, let's go back to our operator overload. Let's see, where is our SuperNumber? Oh, we're in our SuperNumber. We want to, let's close this down. Let me get to the operator overload for plus on this. There it is. Maybe that's all we need for plus. Maybe plus is done. Because if I have 3 meters squared plus 4 meters squared, I'm throwing an exception if the units don't match. Does that make sense?
Yeah.
I think plus is done.
Huh.
I think we need this code that's highlighted inside of our minus as well. Well, wait, we don't, because guess what our minus does? It just creates a negative and then adds them together. So minus is done. Okay?
Yeah.
Good with that? All right, next, let's go into multiplication. Now, what's going on in multiplication?
in multiplication, we need to just, it doesn't matter what the units are.
Okay.
Well, if there's one that has units and one that doesn't, then it doesn't matter.
Okay, and what if I have one that has meters and another one that has seconds?
Then we can't multiply them.
I disagree. We can.
Oh,
the answer is in meter
second,
seconds.
Yeah.
What if one has meters and the other has meters?
Then we can. And it's
And
meters
what's the
squared.
unit? What's the unit?
Meters squared.
Yes,
Or
it's
meters,
meters squared. What'd you say?
Or meters, technically.
Yeah, meters squared.
Same thing. But,
So we need something that knows how to multiply units.
whew.
I know. Remember what a week ago when you said, this shouldn't be too hard. And Dad was like, oh, brother, like this? We are not done. We have to multiply units. Multiply units is tricky. Let's go to some test cases and let them guide us. I'm going to drop a marker here so we can come back.
Is it though? Because, I mean, yes, the meters squared part should be decently simple.
It should be. We're going to need to find the unit, find the powers.
No, we're going to need to find the unit. Yes, we're going to have to find the unit powers for both of them.
Yeah,
Then we're going to have to add those unit powers together.
Yep.
But we already have code for adding. Oh, and we already have code for converting powers to numbers. So we can just use that current code. And then we already have code to figure out, well, we can probably easily write code that says take S. Like if you have two different units, just put them both together and then
Yeah.
M.
We just add those numbers together, right? If we're multiplying.
Well, not add. Well, yeah, I guess in terms of strings, yes, you're adding.
So we're going to need, I'll just write a to-do right here, to-do. We are going to need to multiply the units. It's a little mind-bending what we're going to have to do. But the cool thing about this, Campbell, I think, is it really gives you an appreciation for units and an understanding of what's actually happening when we're multiplying things with units, which happens in fractions all the time. I mean, not fractions, physics all the time.
Yeah.
Okay, there's one other thing that has just occurred to me that's important to make a to-do on. What do you want to say?
Never mind.
You gotta go find our divide. See the operator overload for divide?
Yeah.
See the call to create reciprocal.
Yes. We don't need that for multiplication, do we?
What'd you say?
We don't need that for multiplication. Because that's the create reciprocal just is only for division so that we can make it multiplication.
Right, but so when we divide two super numbers, this is our current code. If we've got a problem now here to do, we need to
units.
Invert the units, which means
we need to invert them, multiply them, and then uninvert them.
Yeah, multiply their powers
times -1.
by -1. Also, I think we've got a problem here already where this is not going to, this new super number here has got problems. This line of code has got problems already. It's a plug-in this I can already see. We need to introduce a local for this, okay? And we're going to do that. And then we're going to say, yeah, this is problematic. I think that we don't want to, this is problematic for us. I'm going to put some to-dos here on the problems we have here. To do, handle the units. We completely lose them. We're going to completely lose our units here. Do you see that, Campbell? Do you see why we're completely losing them?
No, I don't.
Well, because we're returning a new super number because we said, oh, it's a decimal. Let's just take one value divided by another. We're passing in only that number, creating a super number. It has no units, and we return it. We completely lose them.
Yeah, okay.
Okay? Now, over here in create reciprocal, we can fix this.
Wait,
we
might want to scroll up the code just a
Oh, sure. Thanks so much. Create reciprocal, we can put our to-do. It's really, this needs to kind of move into here. And I kind of want to say, let's get out of here. Let's not do this at all. and create. Let's kind of put this inside of create reciprocal. In fact, I'm going to do it. Kind of what I'm about to do. That's what I'm going to do. Because, yeah, that's what I'm going to do. Because it's problematic. This code is problematic, and I don't want to. It's going to require us to do the work twice, and I don't want to do it twice. So let's just go into create reciprocal, jump inside of there. We put our to-do in here. We need to invert the units, which means multiply the powers by -1. Okay? Let's do this. Let's create a test case just for this one right now, since I'm on it. Test unit powers. Got a couple test unit powers out here. Let's do a new one. Test reciprocal. Like that. And I want to say R equals. And I want to say expected is going to be 8x. And then I need to the -1. I'm so glad this is nearby. Let's make it -9 because those are close together right there. 8x to the -9. And then over here, I want to start with 8x to the 9.
Wait, sorry, I just want to try something really quickly. It does work, okay. You can...
Whoops, I want to make this 1 over 8x to the 9, I think.
Yeah.
Although, now we need a space. Oh, see the space? Because if it's a fraction,
right.
It's going to look like it's under the divide sign. We're going to have to modify that. That's in display string, it's somewhere near display string. Let's go find display string, get units display string. That's the one we need to jump to right there. And we're going to get rid of this. We're going back to the really simple, it's got to be this, I think. Does that make sense?
Okay.
Or we have to see if it's a fraction. We could also add code to just say, hey, well, or is it a fraction?
Let's go with the added code to make it a fraction.
Okay, so if it's a fraction.
To say, is it a fraction?
All right, I'm totally with you on that. I love it. So we are in the super number right now. So we can say if the length is equal to 1 and we're not, and type is not equal number type dot fraction. If we're not a fraction and the length is only 1, we can strip that leading space right there, like that. Okay. All right. We're jumping all over the place. So now what I'm looking for is this is an answer right there. So let's run this and see what, whoops, not that, hold on. I gotta do a to_num on this, right? Or it's just, I'm just comparing two strings. To_num. Okay, let's run it. Gonna fail, I'm expecting it to fail. Wait. Build problem. So I got deleted something here. Added something there. Okay. Let's go back to the test. Where was it? There it was. There it is. Okay. Expecting this to fail. Okay, what do we got? Expected 1/8. It got 8x to the 9. Oh, because I haven't done create reciprocal yet. Hold on. Let's make the test case actually correct. Okay. Now I've created the reciprocal of it. Now see what we get this time. I think we're gonna get closer, but it's still gonna fail.
Yeah.
It should be 1/8 with the wrong units.
No units.
We lost our units. Okay, let's go look at create reciprocal.
Huh.
Here, See?
It's the super number again.
Yeah. And here, we lose the units here too as well. No matter what, we lose the units either way and we create reciprocal. Okay?
Yeah.
Let's take a break for a second. What's like the best movie you've seen recently? What you really liked?
Probably The Lord of the Rings
Yeah?
saga. All of that.
We watched that during Bachelor Week, didn't we?
Yeah. I think the second one.
The second one?
Yeah. Because that was the one where
Great
Legolas grabbed the horse and then got on.
Yeah, you liked that move,
Like,
wasn't it?
while
That
it
was
was
cool.
moving.
We rolled back and watched that a second time, didn't we?
Yeah.
We were like, wait a minute, how did he do that? The horse is coming up behind him, he just like reaches around, grabs the reins, hops on the horse.
There was also the scene with the ginormous elephants that he got onto it. And that one. And then he had a rope attached to the kind of the saddle, but it was more like a piece of like a porch kind of on top of the elephant, and he had a rope tied to it, and the porch slipped off the side,
Right.
and he went up
The
onto
platform. It was so fun. Legolas has the coolest moves.
it. Yeah.
Yeah, if I ever write a movie, I'm gonna make like a character like Legolas in there. We'll just have nothing but cool moves. He's gonna be the dad, by the way, in the story. Just cool, just cool
Yes.
moves, just like your dad normally does. All right, what we're gonna need to do here is instead of returning a new super number, we're gonna have to declare a local for it, and then make a call on the local, essentially creating reciprocal units on it or something along those lines. Maybe one call to give it our current units, and the second one to reciprocate those units, something like that. We
We
have to do
already
something.
have something to find what our current units are.
Yes, we have a method to, and we know what our units are. They're in a local, they're in a field called UnitPowers, I think, or something like that. In fact, right down below, you'll see just a little bit here in the code, AddUnitPowers here. So, and it adds it to this field variable called UnitPowers, right there, which is a list of all of our UnitPowers. Okay, so what we need to do is we need to introduce a local here, right there, and we'll call this decimal result maybe. Oh wait, I have a better idea. I like the idea of instead of doing the same thing twice, let me do this. I'm gonna call this result. Rename that to just result. And I'm not going to return it here. And I'm going to set this to null up here maybe. And right down here I'm going to say, hey, if it's null still, then that means we've got a fraction right here. I'll block all of that, and then I'm going to set it here. So at this point now I've got two paths to get to, well, three paths really in the method where we exit. One is where we have a problem where we can't take the reciprocal of 0.
Yeah.
Okay. And I feel like I should have one more of these right down in here, just in case new denominator is 0. I'm going to add that. New denominator is equal to 0, then I'm going to throw an exception there. Okay. All right. Then I've got result, and down out here I can return result. But before I now have to write that code only once. Where I want to say Maybe copy units from. Oh, look at that! I've already got copy units from.
Yeah, we
Okay.
do.
And so I'm going to copy units from, and I'm going to say this. Copy units from this. Okay? So that's going to copy the units, and then I'm going to say, after I've copied them, that's so sweet that we've got copy units from. I love it. We just wrote that, I think, the show. Then I'm going to say...
No, I thought we did it a while ago. Maybe not.
Okay. Create reciprocal units. I'm going to create a new call here. And get ready to write this code, because you're going to write this for me.
Yes.
Declare method.
So we just need to take the units here, turn it into a regular number, multiply that number times -1, and then convert that number to a power.
Kind of, yeah. You'll explore and find it. This is the field variable. Cut this to the clipboard, so you have it on the clipboard for the for each template. So cut it and then type in FE.
Okay.
All right. So now you're going through all the unit powers. We want to create reciprocal units of them. So
Yes.
the variable you want to work with now is this one. This is the iterator variable. You're going through. It's going to represent
Unit
each
power.
unit we have. What do you want to change in that? That's what you have to change.
All right. So we need to take unit power dot power. I can't just do that, can I?
Yeah, you can.
Really? We have code to support that?
No, we don't. But it's not. Power is just a double or something like that. Right?
Oh, right, because we already convert it from.
Yeah. If you
And we
hover
can
over
convert
it,
it to a power later. So all we have to do is do
Yes.
this times equals -1.
and now I think you just fixed the test case. I think. Let's go back to the test case, which I think the fastest way. I don't remember which one it is.
Test reciprocal. It's this one.
That's the one. Okay, run that. See, if we got a shot of that thing working. We're actually testing two things now. That the space before the unit is coming out, it passed. That's awesome. Right? Look at that. We are now logically understanding that the reciprocal of 8 times x to the 9th is 1/8 times x to the -9.
Yeah.
See it? Sweet. Now let's run all our test cases. See if we clean any of these up. Because now we should be able. I think we're supporting multiplication.
We are.
Are we or not? Or did we miss it?
Oh.
We're not.
No, not yet. Right now we're just starting to support division. Or no, sorry, starting to support multiplication.
Okay, wait. Go back to the last test we had on screen. Just setting it down.
Test reciprocal?
No, it's the one with the birds you had. I think it's right there, right off
Test like
screen.
units?
Yeah, like unit division.
Test
Okay.
like units division?
Yeah, that one. Look at line 52.
Yeah. It's passing.
Did
Whoa!
you- But is it because there's a bug in our code?
It's because there's a bug in our code.
Or is it because we're
Wait.
actually checking to see that we are dividing birds by birds, adding up the powers and they're 0, and then returning nothing?
No, but
I don't know. Let's fix 53 and see
Because-
if in the process of fixing 53, if 52 fails.
No, but the power wouldn't be. It wouldn't be 0. It would be
Yes, it would.
-1.
No. You've got birds divided by birds.
Yeah, and we reciprocal. Oh, and then this one becomes -1, right?
Yeah, and -1
Not
plus
this
1
one.
is 0.
Right.
Any
Okay.
power of 0.
I thought it was both of them, but no, only this one.
Yeah, I think there's a bug in our code. I think that what we're going to do is we're going to fix line 53. 52 will fail, then we're going to fix that, then both will pass. That's kind of what my gut feel is.
52 is technically right.
Yes, it is. But what I'm saying is I think there's a bug in our code forcing it to be right. I think we're losing units
Sledgehammer.
in the division operation still, maybe. Maybe. What is the what's the error? If you hover over the red X on line 49, what does it say? It expected and found. Oh, it doesn't say. So we
No,
can
I
look
found
down.
it. I saw it. Oh, it's there for like a second. And then it changes.
Yeah, but it's not. Oh, no, there it is.
It expected 21 birds, but was 21.
Just
Wait,
21. So we are losing the units. Yeah, so we're losing the units, it seems, still with division.
Expected 21 birds, but was 21.
Okay. All right. Do you want to? Let's go look at our operator overload. Let's set a marker here so we can get back.
Wait! There's this piece right here failing now. It's expecting one with no space, but it's getting a space. But that's
It thinks
because
it's a fraction.
we changed that code a little bit.
We think it's a fraction. It thinks it's a fraction.
Yeah.
So we need more than a test of just it's a fraction, but it's a fraction with.
I don't know.
Going to actually show something over, with a denominator. So we need. All right. So let's fix this one right here. Is that cool?
Okay.
That's going to be in something in display.
The piece we just worked on.
Units display string. This is where it is. And this, basically we have to remove the space. Basically we need something different from this. Let's extract this. Let's do this. Let me change this to double equals. Let's extract that. And we're going to call this has fraction, has denominator?
Yeah,
Like
I think
that better. Has denominator, like that. And we're going to say not. So we kind of restore our logic. So if we don't have a denominator, then we can remove the leading space. Okay?
Yes.
Now, has denominator, now we need it to be a little more complex. If the type is a fraction and numerator is not equal to 0.
Wow. Is that it?
Isn't that weird? Has denominator is only true if numerator is not equal to 0.
Well,
Because how else are we going to tell if it's got a
That's
numerator or
true.
not? I mean a denominator or not. The numerator tells us how many of the denominators it has. Right? You can think about it a little longer if you want to, but I'm pretty sure that's...
yeah, no, that makes sense.
Isn't that crazy? Has denominator, the test for has denominator is numerator, not 0.
When you would think it would be denominator is not 0.
I know, that's kind of where I was headed as soon as I got in here, and then I was like, wait a minute.
But
I
they
think
would
that's
both
right.
work, right?
What'd you say?
Would they both work?
No, because my denominator, sometimes I think we do something like this. I've seen that.
Yeah, that's what our code does.
And in that case, denominator is non-zero. But we show this as just that when we display it because it's got 0 of them.
Yeah, okay.
All right, let's see if that now fixes that test case. Looks like did I start on the test case or something? Maybe I did. Let's go back to where we were. Where were we, Campbell? I'm totally freaking looking at this wait, where were we?
So am I. We were somewhere between. Oh.
What's going on here? This shouldn't pass. Oh, it passes because of the argument expected exception. Okay. I was looking at this that's wrong, right? Same thing here, so I just know what's going on. Some comments here. Okay. All right. Wait, where were we, Campbell? We were. Do you remember that at all? One of the things you can do is you can hit Control sign and go backwards through the code.
Instead of Control Zing.
Yeah, exactly.
I like that. That's nice.
Reciprocal units. Looks like we were
Can you do the
there.
same thing with Control Plus on the numpad key?
Were we close to some test here? We did that test. We were
Or on the numpad?
looking around in this space. Oh, it was here. This was coming back with a space in it.
Yeah.
Remember? That's the problem. That's now passing. Okay? Just to double check it, run it one more time.
Passed.
Passing. Okay, good. Working our way through. I think we want to look at this right here. Yeah. Maybe another
Test
well, we could do this. This one right
like
here.
unit division.
Yeah.
Well, this
especially
isn't
21
really
birds.
test like unit division. That was the one right above it. We might want to split this into its own test method.
Okay. You got it.
Because it's test unlike units division. Or not, or test, huh.
Just call it test unit division.
Yeah.
And we'll pop it in there.
But,
Because it's the like units isn't that big of a deal, but what this is doing is we want to make sure we're getting rid of the units. This we want to make sure keeps the units. So we want to debug this. We essentially want to jump into toNum. I think I'm going to just set breakpoint here, hit debug, and we're just going to go in it and drill in and see where we're losing our units and try to keep those back. It could be the code we were just looking at. Maybe that we just didn't finish it out. So now it's got our left and right. It's going into division. Okay, and I hit F11, but it didn't get in there. R equal failed. Okay, looks like on my division operator overload didn't work. So let's drill into that. Go right there, hit F12 to get into our operator overload. We're going to create a reciprocal. This is where I want my new breakpoint, right there. And come back over here, clear that breakpoint. Let's jump in it. Help me find it. Where's the bug? Create reciprocal on the F11. You want to do it? Hit F10. See what's happening.
F10.
Okay, F10.
F10. F10. F10.
Scroll it so we can see it. Okay, there we go. Keep
F10.
going.
F10.
So we have 1/3. Keep going. New numerators 3, new denominators 1.
Yeah.
Cool, cool. Result is equal to new super number, 3/1. Good, good. Copy units from, hit F10 on that. And then let's stop. Let's look at results. Open it up. Look at UnitPowers. Nothing. Did we have units in this one? We had no UnitPowers in this one. Is that right? Let's look at the test. Did I miss something on the test, or is the test right? Nope, there are no UnitPowers here.
So it's just one. No, because there are no units.
So no UnitPowers, so that's all good. We're actually really good still. Okay, so we'll hit F11, create reciprocal units. There's nothing here to do, so we're done and out. And then we return the result. Okay, cool. Hold on, that's reciprocal. Now we're going to multiply them. Let's go inside of here. Oh, shoot. Let's go back up into here. And when I hit F10, it doesn't drill into the operator overload, so what I have to do is explicitly go into the operator overload and
You mean
set a
F11,
breakpoint.
right?
What?
You mean F11?
No,
right?
F12. I'm not. F11 steps in. F12 just moves the caret, and all I'm doing is moving caret so I can set a breakpoint. Now when I'm here and I hit F10, we'll come in and hit our breakpoint. And look what I did. This is why it's not working. Because I just said I did that. That's not going to write the code. So we need to multiply the units. Okay. In fact, we need to multiply
we need
without,
to add them,
without
right?
this.
Because.
So we got, this is going to lose the units. That's going to lose the units.
The units, not the unit powers.
Yeah, so we're going to lose units here. We're going to have to do the same thing before. So we've got this thing called answer right here. Let's come in here. We're going to split the initialization. We're going to come on here. We're going to come up here to the top. We're going to declare it. We're going to set it equal to null, like that. And then right here, we're going to say, hey, answer is equal. Answer is equal to the new super number. Like that. Okay? We still got this to do. We're going to move this down to the bottom once we get answer. We're getting answer one of two ways. Okay? The other way we get answer is down here. We can extract this to its own method here. But we're going to say, call it multiply fractions. And then I can do an else right here. Okay?
Yeah.
Better, right? Easier to read, right? So if the super number is a decimal, right? If either one's a decimal, we're just going to create a new one like that. Otherwise, we're going to call multiply fractions. Okay, cool. But we don't have, we haven't brought over the, oh, look who's here. It looks like Surly's here. We haven't brought over yet the units. So what we need to do, I think, is say, multiply units is what we need, and we need to pass in super number 1, like that, and then I think we duplicate that and pass in super number 2. So remember, with this one we create, when we create a new one, it'll have no units at all.
Yes.
Okay. Now we've got to implement multiply units. Think about how this works in math, right? So I've got super number I'm passing in.
We have to take the units and add them. Or sorry, the unit powers and add them. And we need to just take the numbers and multiply them.
Well, there's no new numbers in here. We're just talking about the powers only, the units and the powers.
Oh, right. So yeah, we just need to take the units, keep them the same, take the powers and add them. Well, if the powers add up to 0, then the unit would not stay the same. It would just go
away.
Yeah.
So what we need to do is this. For all the super number unit powers that we have, what we need to do is we need to say, hey, I think there's a find unit power, right? And what does it take in? It takes in, what is it taking in, by the way? Is it taking in the string? What's wrong with find unit power here? Oh, that's not what I want. Absolutely not what I want. I want something in here. Maybe some super number. Find unit is what I want. Find unit, and it takes a string. So we're going to take in unit power dot name. We're going to try and find the unit. Does it exist already or not? Okay?
Yeah.
So that's the first thing we're going to do. By the way, we're going to double check find unit, make sure it's doing a singular kind of thing on it. Yeah, see, it's calling unit names match. It's making them singular and lowercase. So we can match things up like that. So we're going to have to do find unit. If we find unit is not null, what do we do here, Kim?
Huh. If find unit isn't null.
So find unit is the unit in this super number. We're going to modify one of these two properties, name or power. Which one?
Oh, we're just gonna, Name is unit, right?
Name is like meters or birds or something.
Yeah,
like
name
that.
is the unit.
Yeah.
Power is just the power.
Right.
We wanna modify the power.
Okay, and how are we going to modify the power?
We wanna add it to the second number's power.
Okay, the second number's power is where? Do you see it in this code?
Other unit powers.
I can see it there. Is it, or maybe it's this guy. It's the piece we're iterating.
That's not what I'm talking about.
Okay, it's this one. It's unit power dot power.
Okay.
Okay, so multiply units is there. Now, that's if it's found. Okay? What if it's not found? What do we do?
Oh, if it's not found, then we need to... I'm not sure.
Well, I'll give you a hint. We've got unit powers. This is our list. We're going to need to call add on it. And what do we add to it? A
The
new
number?
unit power. and we need which has two parameters, I think.
Or, I guess.
No, it doesn't have two parameters.
Unit.
Wait, well, can we pass an existing unit power to it?
Power.
Yeah, perfect. Look at that. It'll just copy it over. So we're going to say new unit power and pass in unit power. That's this guy right here in the for each. So just to be clear, right, we're multiplying units of this one. So anything I'm working on that's a field variable, see this white right here?
Yeah.
That's the field variable of our instance. This one is the field variable of the super number that's passed in.
Sorry. Can you say that again?
Yeah. So what we're doing here is we're saying, it's kind of like, the best way to look at this is to think, okay, I am the super number. So think you are the super number.
Yeah.
Okay? And I'm handing you another super number. Okay? So you got that in your hands. That's the parameter.
Yes.
Okay? We're going to go through all of the super numbers, powers, the unit powers in that super number I've handed you. That's what this line of code does. It's in your hands.
Yes.
The super number in your hand. We're going through all its unit powers. It might have meters, it might have birds, it might have meter birds, it might have seconds. Okay? We're going through it. We're trying to find to see if you've got the same unit.
Surly Dad is in the house.
Shirley asks, how are you guys doing today?
We're doing pretty good.
Ow. All right. You want me to start again?
Yeah.
Okay. One sec. Refresh that. Okay. So we're multiplying units. You're a super number. Let's say you've got meters squared already. Okay?
Uh-huh.
Right? So let me ask you, Campbell, what are your units?
Meter squared.
You got meters squared. I'm going to hand you another super number. And it's got only meters in it. Okay? Got it?
Yeah.
All right. So now, this line of code is going to go through every single one. How are you doing, Surly? Going to go through every single one in the one I hand you. See, this is the one I hand you.
Wait, the first one or the second one?
You are the first one. The one I hand you is the second one.
But you handed me two.
Nope. I'm right now only handing you one.
Yes,
You
but
are the
before
one with
you
meters
handed-
squared.
You handed me one. Oh, I'm the one with meters squared?
Yeah.
Okay.
You are meters squared, and I'm handing you one with meters.
Okay.
Just got back from shopping. Surly Dev says, I'm God, thanks. All right. Well, now we know. The mystery has been solved. It could be good, but it's very clearly saying I'm God. So, all right, Surly.
Spelling error?
All right. No, God would not make a spelling error, Campbell. That's
No.
how you know. All right. So one more time. You got meters squared, right?
Yeah.
I hand you another super number that's got meters. So this is the other super number. That's this one right here. We're going to go through all of its unit powers. Which does it have? What does it have in it?
What do you mean? What does? Oh, it has just meters.
Meters. So we're going to go through once in here. Find unit. We're going to see, hey, do you have a unit called meters? Find unit. That's on you. This is on you right here, Campbell. So we're asking you, do you have meters? And your answer is what?
No, I have meters squared.
No, your answer is yes, I do have meters.
What?
You have meters.
I have meters squared. I'm holding meters.
Yeah, but look, I don't care about whether they're squared or not. I just want to know if you've got meters.
Oh.
If you do, you're holding meters squared, right? So what do? Your power, which starts out at 2 plus equals...
You know what we should probably do? We should rename name to unit. Maybe.
All right, if that makes you happy, we're there.
Yeah, because whenever I hear name, it's kind of like confusing for a second, and then I'm like, oh wait, no, it means unit.
Fair enough. Let's clarify it. All right, good. So we find your unit. Do you have meters?
Yes.
And then, so it's not null. Because we found you.
Because
So we say now your power, which was 2, now becomes what?
my power, which was 2, now becomes 1. Right? Or no, it becomes 3.
It becomes 3. Because meters squared times meters is meters cubed.
Right.
Now let's say we do it again. Now this time you don't have any at all. and I hand you birds. I hand you another super
I don't
number.
have any units or any.
You have
I
no
don't have
units
any
at all.
powers. Okay.
You have no units, right?
Yes.
We go through every unit inside of here, and you find you got birds. You ask, hey, do you have any birds? You have a bird?
No, I don't. I
Which
don't
means
have any
this
units.
is null, which means this is not true, which means we jump down to here. And what do we do here?
Here.
This is your
Whoa.
list, your internal list right
Oh,
here.
here we. I go back and I add birds. So now
You
I
add
do
birds.
have birds.
Now you have
So when
birds.
we go through the for each again.
Right. You'll have birds if we get another birds multiplied by. Okay, does that make sense? It's a little confusing, but I thought it would make sense to kind of go through
Yeah,
that.
that makes sense now.
Okay, let me do this. Let me do one other thing. There's a reverse conditional, which sometimes I find this a little hard to read. Right there sometimes, and I like to have the opposite of that. So I just come in here and use CodeRush's reverse conditional on there to do that. To just basically swaps these two statements and inverts this logic. So now I have a find unit is null. Then we're going to add the unit. Otherwise, we're going to add the powers. That's multiply units. What's cool about this is that these two in a row, the first one's going to add. The second one is going to also kind of add. So this should theoretically solve some of our problems here. Edits were made. Okay, so we're going to need...
I think it will get us closer to solving some of the problems, but I don't think it will completely solve some of the
I think that's a
cases.
fair prediction. Should we go back to our tests? Let's now see what happens here if we just run.
Wait, we might want to just test all of them. Run all of them.
Well, I hear you, and I want to let me test that. We will test all of them, but let me just try this one.
Okay.
Okay, because I want to see if
Yeah, that's okay.
I want to do this one piece at a time. I want to see if this works. That works.
Yes.
So now 7 birds divided by 1/3 is 21 birds.
Great.
Sweet.
And multiplication should now work too. Right?
Hold on. I want to see
Did?
if this works. Right here. I think this is going to fail. I think it's going to say birds to the 0. See, look, it does. See it? Birds to the 0.
Oh, come on.
Well, we need to clean up any units that are 0. Because it's we equal to
Yeah.
multiply by 1, right?
I
So
forgot to do that.
let's
Wait a
go
minute,
to...
wait a minute.
What'd you say?
We need to modify our 0. I believe that currently it's just the degree sign when there's an actual 0 in China.
Okay, we can do
We
that
can do
too.
that later
I
though.
want to do this in multiply units, I think, or maybe we'll have our own. Let's do this. Maybe we have our own method that says clean up. So we're going to say answer, clean up any 0 power units. What do you think about that as a name?
Yeah, I would say that's a good name.
All right, and we put it right here. We're going to do something similar with, almost similar to this right here. UnitPowers, like this. I'm going to write this bit of code because this is a little non-standard on here. I'm going to do a for each to 4, then I'm going to reverse the for loop.
4 to 4 each, or
No, I'm going to get, hold on. I'm going to reverse the for loop. Oh, the mouse is over it. Okay.
reverse 4 statement.
Yeah, so it's starting at the end, going back to the beginning is what I'm going to do.
Oh yeah.
And the reason I have to do this is because I'm removing elements. If I remove them from the back to the front, it doesn't impact anything. But if I'm going from the start to the end and I remove them at the beginning, then my index into them is messed up. What are you smiling about?
I just realized I just scratched my head into the microphone, not realizing that the microphone
Don't
was
you
right there.
ever do that again. All right, so now what we're going to do is this. We're going to say, hey, if UnitPowers of I dot what? What's our test going to be? What do we do if we want to remove it?
Dot powers. Or
Dot-
no, dot name or unit.
Dot
Because we
unit?
want to get rid of it, right?
Well, I'll show you. Here's the code to get rid of it. The code to get rid of it is going to be UnitPowers
Oh.
dot remove at passing in the index I. That gets rid of it. What's our test going to be right here?
Yeah. Here we want to have power. If power is equal to 0.
Okay? If power
Zero.
equals 0. I can write that and get my fingers off of it. Then we're going to remove it. All right? Let's see if that fixes.
So that for statement just goes through each and every power or each and every unit, and it checks to see, does this unit have a power of 0? And if so, deletes the unit. Because if it has a power of 0, it means that it's itself times itself 0 times.
Right,
So
exactly. So which is equal to 1. Right? Anything to the 0 power is 1. We have to count.
And the reason it's 1 is because it's itself times itself, however many times the power is, plus 1. Right?
Yes.
Yeah.
I think that's right. Yeah, well, not plus 1, times 1.
Times
it's
1?
It's 1, the definition of anything to the power is 1 times
1.
that unit,
Times
the number of
itself
times
a
of its
couple
power.
times. Why is the 1 times there? Just so that 0 is cleaner?
Why is the
1
1
is
times
cleaner?
there? Yeah,
Yeah.
And that's my definition. So it's cleaner. So actually the whole thing makes sense. If I say that,
And you can do it easily. It's not, doesn't affect anything.
Yeah, if I say x to the n power is equal to 1 times, x times x, whatever,
N
as many
times.
n's, n times. Well, if n is 0, then we still got at least
1.
1
Yeah.
as the answer. That's why I like seeing that as the definition.
And technically you're not affecting the answer. But I mean technically you are.
Yeah, so now last time we got it was equal to 14 verts to the 0 power.
But now we should just get 14.
Yeah, now we want to see a pass test. Good. All right, now let's run all the tests. So we're getting better. Let's see how we're doing. We've got multiplication. I think we've got addition and solved as well. And if we've got multiplication, we've also got division. We may actually have a lot of these more passing. What is happening?
Negatives. Negatives.
Hover over the X and see what the problem is here. Oh, it's the space with a V.
Oh, it's
only the
not
space.
simplifying. Nope, it's also not simplifying.
Okay, let's simplify
Why
it.
isn't it simplifying?
Why does it go to ninths? Let's.
Oh, because when it's
doesn't make sense at
Our-
all.
Oh, we have to have code in our addition thing to say if the denominators are actually the same, don't try to change it to the closest.
I see.
Right, because our addition isn't finding the what the nearest common multiple, I think is the term for it. It's just looking for that times the other one, which still works, but it doesn't work if the denominators are the same.
Yeah.
Or maybe we just have code to simplify it at the end,
Well, I can make a simplified call on it like this.
and then it's still the space.
Let's run it now. I added a space here because we decided that's a little. It's still -3/9. Simplify is not working on -3/9.
We need to put a simplify not there, but in just our addition call.
Well, I think our simplified call is not working. If it's a negative number, maybe, or something like that. We'll have to look at that. We'll save that for next Friday. Do you want to end the show?
Sure.
Or are you right now?
Yeah, I'm fine with that.
End of the show? All right, so we're getting closer. Still
So
got
much
some
closer.
test cases failing. The cool thing about these test cases, though, Campbell, is if you don't have them, right, you
We wouldn't
think things
ever know that whether or not this would work. Or this
right.
would
You
work.
think things are working. You don't realize you've broken something, and you ship the product. And
Yeah.
now people are like, "What? Why do you have bugs in it?" Right? So test cases are so important, especially for something like what we're doing here. We've got this kind of low-level kind of structure.
And even with them, we wrote them, so we could have missed a ton of things that we meant to have test cases in, or that, and those it might still work, but we might still have just missed it when we needed to put a test case for it.
Yeah. Yeah, so let's do this. I'll get a raid going, and you can start up source tree
Source tree.
and get a check-in going on the code. Make sure everything's saved. Always a good thing. Sometimes you can make changes without saving them.
Oh wait, no, that's not where I want to go. I want to go here.
Send you guys over to Lana Lux,
I want to go here.
and we will see you on Friday.
Save all. Yes. We'll be Yeah, we'll be here on Friday.
All right, kids. Take care.